Hello guys, welcome to the Innovation Lab. In this video we're going to show you guys how you can build a super simple 36 volt 2000 watt DC power supply that you can use for multiple different applications, and you're going to be able to make this power supply for less than $60. Alright, so given the current technological evolution that the world is going through right now, with a lot of things becoming battery powered, ranging from vehicles to scooters to bicycles, e-bikes, and even lawnmowers, different kinds of home applications are becoming battery powered. And what amazes me is that a lot of people are actually making the effort to build these machines as their personal DIY projects. So I was thinking that having something like this, something that is easy to assemble, something that is super cheap and affordable, will go a long way to help those people out. And the cool thing is that this entire project gives us an opportunity to recycle these server power supplies that would have ended up in landfills. So in a way, we are actually going to be helping the planet by building something like this. Alright guys, let's get started. In our last video, we showed you guys the initial testing of our limitless power DC to DC boost converter concept. But with that testing, we had some limitations because even though the design can take an input voltage range of about 10 to 60 volts, we were only able to drive it with a 12 volt input. So that means that our output was kind of limited because of the limitation in the input voltage. So this is the reason why we're going to be making this 36 volt 2000 watt power supply to help us get through the second phase of the testing on this limitless power DC to DC boost converter. Alright guys, and what we're going to be doing here is very simple. So this power supply here is already configured. As you guys can see, we have a positive and negative, so we're going to be doing the same exact thing to the new power supplies. So we're going to configure them so to allow us to stack the converters in series essentially. So we're going to make a stack, a 2000 watt stack, so that way when we bring in our 110 AC or 120 AC here, then we come out here and we connect all the 12 volt outputs in series to give us a 36 volts 65 amp power supply. Alright guys, that's really what we're going to be doing in this video. It's that simple, but there are some things that we need to do inside of each power supply to make this whole connection work, and I'm going to be showing you guys step by step how to do it. Alright, let's get to it. So the cool thing about this project is that these are really universal power supplies that you can easily find online for less than $20. I found these ones on Amazon for less than $20 each. So and these power supplies are really universal, and what I mean by that is that you can see here, these power supplies can take an input voltage range of 100 to 240 volts, and they can operate within input frequencies of 50 to 60 hertz. Yeah, so they can deliver up to total on the 12 volt bus, they can deliver up to 65 amps that you can use for different applications. Also, another cool fact about these converters is that they are quite durable, quite reliable, and when you use them, you actually, in a way, you will be saving the planet, because these converters would have ended up in landfills if they are not properly discarded, and that will not be good for the environment. So in a way, by doing this project, you're actually helping to save the planet. Alright guys, the first thing we need to do to these servo power supplies to be able to use them is to isolate the ground from the negative terminal of the switch mode power supply. So, and how we do that is to remove this screw here, because that's the screw that ties the negative output to the chassis ground of this servo power supply. All right, so let's go ahead and take it apart and do that. And after we do that, we are gonna essentially have to do the same thing to this servo power supply, which will be kind of the third power supply, since we're gonna have 3 of them in series. All right, let's get to it. All right, so I believe I have removed all the screws, as you can see here, and on the side. I believe that's all of it. So now we're gonna carefully pry this open, and it comes off very easily, and we have to slide this out, and there you have it. So what we have to do now is to remove this screw here, and we put in like last time I used an electrical tape to tape it off to make sure that the negative bus still doesn't make contact with the chassis of the converter. All right, so I just want to show you guys everything I'm doing so you can easily do this. So your end goal is to get this board to be a little bit loose, to where you can actually go in and put in like your insulating tape in there. And so what I had to do to get that to work is essentially I removed this screw here, which is the grounding screw, and I had to remove this one as well. I'm gonna put it back. So this guy here, so I kind of loosened this screw here a little bit, and also there's one in here a little bit as well, and these screws correspond to, as you can see, the mounting holes here. This guy here, and these two. So as long as you have them a little bit loose, you should be able to easily access that point. All right, so this is exactly what I was talking about, and it was hard for me to do this while I was filming at the same time. So what I did was to, as you can see, pry this open a little bit to allow me to slide in 2 layers of electrical tape in here. So now I'm just gonna trim it off a little bit and fold it back here, and that is it. We are done. So now that's exactly how we want it to be, and this will prevent the negative terminal of the power supply from touching the chassis ground. And we're gonna go ahead and test it. All right, so this is the negative and this is the chassis. As you can see, there is no connection, there is no shorts, it's entirely open. Now if we compare that to this power supply, the one we have not done, let's see how this one compares. So this is the negative terminal. As you can see, this is what we don't want, so we need to do it on this one as well. But naturally, this is how the servo power supplies are designed. I believe this has to do with the design for grounding protection and stuff like that. But you know, there is no way we're gonna make this work without disabling that grounding. All right, so with that completed, the next thing that we need to do is to cover it back up, and then we go ahead and add our output enable resistor here, such that when we plug in our input power, we will get our output will be enabled. And I'm going to be using about 30 ohms, somewhere between 33 ohms for that. All right. Alright guys, we have done all the prep work that we needed to do for this servo power supply, and now let's go ahead and test it. So we have our multimeter connected, as you can see here, positive probe to positive and negative probe to negative. So now we bring in our 120 volt AC. Alright, as you can see it, we have 12.3 volts DC coming out from the servo power supply, showing us that everything works as we expected, and that one is complete. We're going to repeat the same process for this servo power supply, and I'm hoping that it goes well. Everything works for this one as well. All right. Alright guys, so here we have everything that we need. As you guys can see here, we have our servo power supplies. So these are the 12 volt servo power supplies, and we're going to connect them in series to give us the 36 volts that we need. And here are the 3D printed PLA mounting brackets that we're going to use to assemble the fixture. And here are our connecting cables. So the connectors that we're using here are the XT60 connectors. So we're using two of them in parallel. So that means that these cables or these connectors should be able to handle about 100 to 120 amps DC going through them. And these here will be the actual output connectors that will connect to the load. Alright guys, let's go ahead and put everything together, and finally we're going to do some testing on it. Alright, let's get to it. Alright guys, so we just put together this test setup to allow us to conduct some real load testing on this power rack that we just built. So what we have here is, of course, we have the power rack here, and we're going to be testing it using the DC to DC boost converter that we built. So, and the goal for that is to step up the voltage from 36 volts to 48 volts that we're going to use to drive our heaters right here. And the reason for that is these heaters are rated for 1000 watts at 48 volts. So for us to be able to maximize the load that we're going to put on the system using the two heaters, so we needed to dial up that voltage to 48 volts. Also, as a matter of fact, the testing of this boost converter here, this is what we are calling our limitless power boost converter design concept. It was because we needed to create a high power input, and that was what led to the design of this power rack. So we wanted to know if we will be able to connect the server power supplies being 12 volt output. So we connect 3 of them in series to give us a 36 volts, but we don't know if these power supplies will actually work well together. So now we are going to be testing that, and to help us figure out what is happening, how much power is going in and how much power that is going to the loads. So we're going to be using this digital clamp meter here, which provides a little bit more convenience and maybe a better accuracy. So we're going to be using it to monitor the input voltage going to the DC to DC boost converter, and we're going to be using our fluke meter here, and we're going to be using our fluke DMM here to monitor the input voltage. On the outputs, the digital power monitor will give us all the information that we need: output voltage, output current, output power going to our heaters. And we are going to use this fan here to make sure that our DC to DC boost converter doesn't overheat. Alright guys, let's get started. Alright guys, that's it for this video. Thanks for watching. As we have seen during the testing, we were able to use this power rack to supply an input power of 36 volts at 46.4 amps going into our DC to DC boost converter, and with that factoring efficiency losses, we were able to deliver about almost 1.5 kilowatts going to our load. Alright guys, this is just a test for this power rack that we just built, and we built it because we needed a power supply that is powerful enough to allow us to conduct proper testing on this DC to DC boost converter concept. Alright guys, if you'd like to see the testing that we're going to be conducting on this DC to DC boost converter to measure efficiencies and try different things and different inductor designs and everything, be sure to subscribe to the Innovation Lab so you get notified as we're making those videos and making some progress on this design. Alright guys, don't forget to give us a thumbs up. Alright my friends, I'll see you guys in the next video.